fact that I'm turning it upside down means that this is something that you've never seen before. It's not a magnet, it's something called a superconductor. And we've only discovered it in the last 100 years or so. Now, what is going on here? When the magnetic force field of the magnet comes close to this material, it causes little loops of electricity to form inside the material that circle the force field. And those loops don't want to move. And so if I take it further or closer, it resists, it kind of wants to stay there. Now, what's really special about these sort of loops of electricity that go on in here is that they're not electricity in the way that we're used to it normally. Normally, we're used to electricity in the form of electrons. They're like little particles. They bump into each other. But in a superconductor, the electrons have been paired up. They buddy up with another electron, and that turns them into these waves. They behave very differently, and this is the beauty of quantum mechanics, that you need to be able to describe things that you thought you could describe one way in a totally different way. And you can see it's falling. That's because it's hot outside. At some point, this superconductor will no longer superconduct. It'll be too hot. It undergoes a transition much like ice melting into water, right? It's undergoing a change. That change is just happening at a very low temperature.